First, we're going to start with adding polynomials. Okay? Adding polynomials. Let's cover just a little bit of vocabulary before we go on. Does everyone know what October means? I'm just teasing. Does everybody know what adding means? Also just teasing. Okay, let's look at this word. This is the word we need to talk about. What does that mean? Many, right? What does that mean? Nomials. Means numbers, right? The first part of it, it's gnome, like number, okay? So it actually means numbers or terms, okay? Because sometimes, as much as I try to tell you that x is a number, we usually refer to it as a term, right? So many numbers or terms. It could be a binomial. What's a binomial? Two numbers or terms. It might be a trinomial. Three numbers or terms, right? We don't really have quadnomials, okay? Because that's kind of awkward to say. I suppose you could, like, technically have it, but once it's past 3, it's just a polynomial, okay? Does that make sense? Okay, so when we're adding, there's really one main thing that we have to keep in mind, okay? If we have x squared plus x squared, what are we going to get? How many x squareds do we have? We have 2 of them. We have 2 x squareds. When we're adding, do we mess with the exponents? No, not at all, right? When we are adding, we do not mess with the exponents at all, okay? So what if we had I'm just going to go from this right to a problem you might see on your homework, okay? We're not going to do little sissy-pansy problems. You okay with that? Because, I mean, after all, it's adding, okay? So how about 4x to the third plus 5x squared plus x plus 3x to the third plus 7x squared plus 11. What do we need to keep in mind here? The exponents, right? In a way, when I'm adding these two things, can I just go ahead and combine these two and get like 9x to the fifth? No, because in a way this x to the third and this x squared is almost like this is an x and this is a y. Can you add x terms and y terms? No, you can't add these type of terms either because they're not the same. They're not exactly the same. I get that they're x's. I promise I get that. Okay? But they're not the same kind of x's. All right? So what goes with the 4x to the third? The 3x to the third. Tell me what the parentheses mean in a problem like this. It's like I'm adding this one and this one. Do I need to rewrite it without the parentheses? Not really, right? It's almost like I don't even need them because I'm adding. Does that make sense? So if I have 4x to the third and 3x to the third, what do I end up with? 7x to the third. That's what I got when I added the x to the third terms. Okay? What goes with the 5x squared? The 5x squared and the 7x squared go together. And what do you get when you have 5x squared and 7x squared? 12x squared. That's what I got when I added the x squared terms together. Okay, so what goes with the x term? Wait, what? We can't add anything to it? Can I add the 11 to it? Does the 11 have the x? No, so I can't combine them, right? So I would just get plus x and get that. And then I have the 11. So I guess if you're being technical, I am adding the 11 to it, but I'm certainly not combining those two terms, am I? Okay? And that's just the answer, guys. That's it. That's all we can do with it. Is there any time ever that I could go any further? Like if somebody told me what x is, right? I could substitute that in and go further, right? But at this point, can I combine any of these at all? No, I'm done, right? What were you going to say? Mm-hmm. Like if we were trying to solve it, right? If it equaled something and we were trying to solve it. Absolutely, that's true. Okay? That's another thing that we could do something with, but I don't know that yet. Okay? So now I'm done. Now we go on to the next problem. That makes sense? Do I need to do any more examples of adding polynomials? We good on that? All right. Subtracting polynomials. Three x to the fifth minus 2x to the fifth. What does that equal? Okay, so this is what you said first. And then you corrected yourself to just say x to the fifth, right? So which one of those is right? Both of them. Which one is righter? Is there one of these that is more correct? No, it's not, right? They both mean exactly the same thing. For people like me who's a visual learner, sometimes I need the 1 to remind myself that's a 1. Okay? If you're not a visual learner, probably this is okay. If we're taking a quiz or a test and this is the answer, either one of these will be 100% right. You okay with that? Okay. So, again, just jumping right in. What about 2x to the fourth plus 3x to the third plus 5x squared minus 4x to the fourth plus 2x to the third minus 7x squared? Tell me about the parentheses in this problem. Do they really mean anything? Well, just like last time, I'm taking this number and subtracting this number, but the problem is it does really matter this time, doesn't it? Because I'm subtracting everything in these parentheses. Every single term I'm subtracting. Okay? So I kind of got two choices. Here's my first choice. I can go term by term, just like I did last time. 2x to the fourth minus 4x to the fourth. What's that? Negative 2x to the fourth. And that came from combining the x to the fourth terms. You okay with that? And then I have 3x to the third minus 2x to the third, which gives me x to the third, or 1x to the third, right? And that came from combining the x cubed terms. And then I have 5x squared minus a negative 7x squared, which gives me 12x squared. How many times do you think people mess that part up? A lot, right? They forget and they just go 5 and negative 7. Oh, that's negative 2, right? They forget that we're subtracting. If you can do it that way, that's a perfectly fine way. I just showed you what I did and I got exactly the right answer. Okay? But here's another possible way to do it. I'm going to rewrite the problem this time without the parentheses. 2x to the fourth plus 3x to the third plus 5x squared. And I'm going to subtract every single thing in here. I'm going to subtract a 4x squared. I'm going to subtract a 2x to the third, and I'm going to subtract a negative 7x squared. Well, what happens right here? What happens right here? If I'm subtracting a negative, you're adding. What did I say? Oh, thank you. Thank you. I appreciate that. But do you see how more people would get it right this way? Or let me change that. Some people would be more likely to get it right this way. Not more people, because some people can do it just fine this way. Okay? So here's what a lot of people don't like, is that you can't do this in the calculator. Well, the calculator is only as smart as its user, right? You need to know. Can you do 2 minus 4 in the calculator? Yeah, I don't know why you're doing 2 minus 4 in the calculator, so hopefully you're not actually doing that, but you can, right? You can do 5 minus a negative 7. You just have to remember. That's the biggest part of that, is remembering. that make sense? Okay. Any questions on subtracting? All right. So what's next? Multiplying. Multiplying is a little bit more involved, just like it is normally, right? So let's start off kind of easy. Let's just say 4 times x squared plus 5x minus 3. What do I do with that 4? I distribute. You do not know how happy that it makes me to know that you know that word. Okay, I'm almost crying inside of my heart right now. Because I distribute this 4 to that term, and that term, and that term. Every single term. Okay? What is 4 times x squared? 4x squared. What is 4 times 5x? 20x. And what is 4 times negative 3? Negative 12. Can I combine any of those terms? Nope, then I'm done. What if it was 2x times negative 3x squared plus 2x plus 5? Do I do it any different? No, I still am distributing this first term times every single term inside of the parentheses. But I do have a major difference here now, don't I? I'm multiplying by an x. Let me remind you that if I have 2x times negative 3 times x squared, wouldn't it be like that with the negative 3 in the parentheses? Well, what's 2 times negative 3? Negative 6. How many x's do I have? 3. X to the third. Uh-oh, I messed with the exponents. Is that okay? Yeah, not only is it okay, it's necessary, right? Okay? Now, I don't want to have to do this every time. I don't want to have to write it all out like this every time. So can you remind me of the rule when I'm multiplying like bases? What do I do with the exponents? I add them, right? What's the exponent on this x? 1. What's 1 plus 2? 3. Can I write it out like this every time if I wanted to? Yeah, but I promise you don't want to. Okay? It's much easier to remember the general rule. Okay? It's not a trick, is it? There's no fancy weird trick that suddenly just poof shows up. We're literally adding the exponents when we multiply like bases. So what should the next term be then? What is 2 times 2? 4. And how many x's do I have? 2, because I have a 1 plus a 1, so I have x squared. That's exactly right. Okay? Last one. What do I get here? 10x. Questions? You good? Okay. Now, the next one is where, the next 3 examples is where we have lots of weeping and gnashing of teeth. Okay? Let me show you what I mean. 2x plus 5 times x minus 3. What's the first thing that most people want to do with this? FOIL. Okay? FOIL is what you learned when you were just a wee baby in Algebra 1. Okay? When you were a baby, when you were a little tiny baby, a little infant baby, you learned how to do FOIL. Okay? I'm not saying it's wrong, because we all learned to eat with those giant plastic spoons when we were babies so we could hold them in our hands. Do we still eat with those spoons now? Probably not. Maybe you do. I'm not judging you. Okay? But it was a fine way to learn it. But now it's time that we do a little growing up. Okay? I was super excited when he knew that word. What was that word again? Distribute. Okay? Because that's what we're actually doing. FOIL is a trick to help you remember stuff. I don't like tricks. Do tricks always work? And once we get into Algebra 2, they work less and less. Okay? So let's do this one with the distributive property. That means I'm going to take this and I'm going to multiply it times each term in the second. Does FOIL work here? First outside. Then yes, it does. right? So what is 2x times x? 2x squared. And what is 2x times negative 3? Negative 6x. And then I take the second term, or in the case of FOIL, the inside and the last, right? But I distribute the second term to each term in the second parentheses. So I get 5x minus 15. You okay with that? Now, is there any terms I can combine here? Those two right there, they're both x terms, right? So I'd end up with 2x squared minus 1x minus 15. Now, what do some people write here instead? Just minus x, right? That's okay. We all know that. We're good with that, right? And that's no problem, was it? That problem was no problem. But here's one that is. Well, it's a problem. Oh, there's nothing supposed to be there. Ignore that. Ignore that. Okay? It's only a problem if you're trying to FOIL it. Uh-oh. So if I do first and outside, I totally skip this term. Am I allowed to do that? No. So once we get to trinomials especially, and anything beyond that, we can't use quote-unquote FOIL anymore. We have to know what FOIL is causing us to do. And we know, you guys know, because you're a little bit more grown up, right? That FOIL is the distributive property. I'm going to distribute this 2x times the first term, and what do I get? 2x cubed. Now I want you to watch how I write this, because some of you only know one way to write this, and I want you to make sure to know that there's two or more, but at least two. Okay? And then I'm going to multiply the 2x times the negative 5, and what do I get? Minus 10x. And then the 2x times the negative 3, and get what? Negative 6x. Whoops, what did I forget? Squared. Thank you. You okay with that so far? What do I do next? 3 times x squared. What do you get? Look where I'm going to put it. Why would it? Yeah, it matches up, doesn't it? It's the same kind of term as that one, so is it okay if I write it right underneath that? Okay, so then what's the 3 times the negative 5x? So I'm going to put it right here. Why would I put it right here? Same kind of term. And then the 3 times the negative 3 and get negative 9. Now it's one of those vertical addition problems, right? I'm not trying to add horizontally all the way across. I've got 2 levels. And I can just add straight up and down, kind of like I'm used to, right? So I have 2x to the third minus 7x squared, right? Because I have a negative 10 and a positive 3. And then here I have plus 9x. And then minus 9. You okay with that? Any questions? Did I mess up anywhere? You're looking at me strange. Oh, that's just how you normally look at me. Okay, sorry. Okay. My Call of Duty headset? Yeah. I could beat you. Questions? One more example. 2x squared minus 3x plus 5 times 4x squared plus x minus 6. Now we're really in trouble if we're trying to do FOIL, aren't we? Okay? We really need to make sure we're doing the distributive property. Okay? 2x squared times 4x squared. 8x squared. Right? 2 times 4 is 8. 2x squared times x. What? You guys didn't fix this for me. I'm sorry. That's why you were looking at me funny this time? Okay, sorry about that. Nope, that was my fault. I wasn't trying to trick you or anything like that. I just messed up. 2x squared times negative 6. Negative 12x squared. Now we go to the negative 3x next, right? Negative 3x times 4x squared. Negative 12x cubed. Negative 3x times negative x. Negative 3x squared. Negative 3x times negative 6. That's 18x. You okay with that? 5 times 4x squared. 20x squared. 5 times x. 5x. And then 5 times negative 6. So I have 8 x to the 4th. I have negative 10 x to the 3rd. Right? Positive 2 and negative 12, that would be negative 10. I have negative 12, negative 3, and positive 20, so that would be 5x squared plus 23x minus 30. Now, okay. I'm just showing you I like adding this way because if it was all long and it's really easy to get lost. I'm not saying you can't do it that way. It's perfectly fine for you to do it that way. But this is the right answer either way. Okay? So you have some homework on the sideboard. We will have a chance to work on it in class tomorrow though. Okay? Have a good day. Peace.